Um, this here is what I'm revisiting to study some more. I call it a field of nines, but actually it's a bulk field of nines because there's different fields that come in rows. Um, and there's three different fields that make this up. And I'll show you on this paper in a second. But here's the first field. Without the nines, it's 8, 7, 6, 5, 4, 3, 2, 1, 7, 5, 3, 1. What these are, all these are like 98, 97, 96, 95. When you add 9 and 8 together, it leaves 8. When you add 9 and 7, it leaves 7. So that's multiplied one time. It's just one time. Those reduced digits. For this level, it's multiplied two times. So 98 leaves 8. But 8 times 8 is 16. And then the 1 and 6 from 16 added together gives you 7. And like here, 97 multiplied or added together leaves 7. And then multiplied 2 times. 7 times 7 is, or 2 times 7 plus 7. 7 times 2 is 14. And you take the 1 and 4, and that leaves you 5. Same thing with this, 96. You, multiply it 3 times. 6 times 3 is, or 96 leaves 6. Okay, and multiply 2 times is 12. And the 1 and 2 make 3. And so you see how I get all these numbers. Each generation is multiplied 1, 2, 3, 4, 5, 6, or whatever. And but first the digits are added together, the first addition, and then it's multiplied, going down to 10, I guess, or it starts over at 9. So that's the first generation. Right here is the first generation again without the nines border, 9 border. You just assume the border to be there. And these 9s appear. And these 9s go throughout these generations. And these are just going down the series of numbers from 100 to 1 or 0, whatever. This is the third generation. And you start seeing these patterns pop up. Notice some 2, 4, 6, 8, 1, 2, 3, 1, 3, 5, 7, 4, 8, 3, 7. These patterns. I'm just now rediscovering these and trying to study them some more. And this is the 5th generation, 6th generation, 7th generation, 8th generation, this is the 9th generation, and this is where it starts over on the 10th generation, which is this right here, but it's just a part of this because this whole pattern shifts. And I'll show you what I mean. These patterns, if you notice, there's 7s included here. Well, that's another field. There's 3 fields that make up this bulk field of 9s. First, there's always the 9s, 6, 3 9s. The 9s are shown predominantly, I guess. And then here's 7s on this first plane or pane. And there's 1s. If you see the 1s in green. And then on the 4s, to make patterns. If you notice these patterns, sevens again, ones, fours, sevens, ones, and fours, and it's because all these are related. All the sevens, you get the sevens and the ones and the fours by multiplying instead of adding, and you multiply 8, 7, 7, and 5, and I believe that's 1960, 1960, and that leaves you with, to reduce to 196. The 9 is out, so the 1 and 6 left gives you 7. And the same thing with these ones, 2, like for instance 2, 1, and 1 and 5 together gives you 3, 4, 5, 6, 7, 8, 9, and or I think let's multiply it. 2 times 1 is 2 times 2 again is, or times 1 again is 2, times 5 is 10, and you take the 1 and you discard the 0, so that leaves you with a 1. So sevens and ones and fours are the multiplied in between places in this patterns, in these planes. And last thing that I left out on my studies of this is these stripes for a deeper stage of multiplicative reduction, because if you were to include the zeros in 8, 7, 7, 5 in the multiplication, which is 1960, then in the second stage it would multiply down to 0. The same with all these. But in this stripe, and this stripe that goes on through here, if you multiply to the second stage, you're left with the number 2, 6, 8, 3, just random numbers, as far as I can see. And I've only just begun to study these zigzag stripes. This is the first pane, and it's a further multiplicative reduction that ignores the 0. So there's the 6, 3, 9s that make up the main pane, make up the main field. It's in every pane. Then there's the 7, 1, and 4s that repeat through each pane. 7, 1s, 4s, and I've already went through here. 7s, 1s, 4s, 7s, 1s, and 4s in the back. So I hope this gives me something to try to discover more about. But thanks a lot.